Okay, guys, for the second part of this class, I wanted to pay attention to the process you did as previous research in our last class. So please take notes about everything and also open your notes from previous class about the limiting reactant. So let's get started. What I am proposing for today's class is to analyze the following. So as you can see in this moment, you have this exercise. You see, I'm saying that you've got this a useful insect repellent, which is that one, C11H21NO3. So girls may be asking whether if it works as an undesirable male repellent. Is synthesized. What is it synthesized? Like this one is synthesized for doing the following. You put the two compounds there, right? And then the product is the, obviously in this moment, the repellent. As you can see, that one, the repellent. So here you put this, you synthesize this with this one, and you obtain this insect repellent and with this byproduct, which is hydrochloric acid and stuff. Well, if we analyze that before getting started to do any other sort of calculation, we must balance the equation. Let's see how are we going to balance it up. We have 7 carbons and 4 carbons, 11 carbons, so cool. 11 hydrogens plus 11, 22, 21 plus 1, 22 hydrogens are okay. 1 chlorine, 3 oxygens. So that equation is balanced. So look, yes. I am going to type the numbers there just for, you're not supposed to, but I'm putting there for you to remember that the relationships in this moment are 1 to 1. Okay? Here, I'm going to put it's 1, and also here, let's pretend it is 1. So 1 mole to 1 mole to 1 mole to 1 mole. Okay, looks like it's 1 to 1. So first of all, how much is needed to create 500 grams of the repellent? Okay, so let's go to the first part. I'm going to make a little bit of space for solving that exercise. Let's get to work there. So you underline, right? How much C7H11Cl3 is needed, right? Okay. And to create 500 grams of the repellent. When I'm saying the repellent, I am meaning this specific compound, C11H21NO3, okay? So what is the meaning for that? That we're moving specifically, right? We're moving from where? From the grams of the repellent, from 100 grams of the repellent to the, right, C7H11, so on. So this is the data they are giving you. You're moving from here, there. In the reaction, to be precise, what you're moving from the repellent is from here to where? To specifically C7H11 there. So that is the way you're supposed to solve the exercises. Okay. So then you write the data, 500 grams, right? You're supposed to put that there, 500 grams, let's put it, 500 grams of the repellent, right? What's the repellent? C11, right? H21, NO3. That's the data I just got. And also then it says, let's pass to the other part. Let's transform that to moles because the reaction is balanced according to moles. So 1 mole of the repellent, C11, H21, NO3. C11, H21, AO3. So what is the mass for that one? According to the calculations you put that, it looks like you put 11 times 12 from the, which is the mass of carbon, plus 21 hydrogens, which is the mass of 1, plus 14 from nitrogen, plus 3 times 16, which is the mass of oxygen. In total is going to be, right, 215 grams of the repellent of C11, H21, NO3, right? And also, once you have passed it to moles, it says how much is needed to create 100 grams. You can, you could pass it to moles if you want to, but I think it's better if you present the answer in moles. So then 1 mole of the, you pass it to, yes, of C11H21NO3, right? And that must be passed into the upper part to the conversion factor from the chemical reaction because it says to the C7. So it's 1 to 1, so you put 1 mole of C7, right? H11ClO3. And then in the lower case again, right, you would have to put 1 mole of that thing, C7 of the reactant, right? H11ClO3, and that in grams. What's the mass for that in grams? If you add, according to the periodic table, right? C7H11ClO3 weighs exactly. Remember not to round the mass of chlorine, which is according to the periodic table 35.45. You keep it there. So the mass is going to be for that one. It says C7H11ClO3 after adding into the calculator 178.45 grams of C7H11ClO3. Okay, once you have done all of that, then you just close the conversion factors and stuff like that, right? And then I'm going to do this, right? Remember that all of the conversion factors are just fractions. So you must make sure in all of this process I just did, you can cancel out grams with grams, right? Moles with moles, moles with this, with moles of this. And at the end, you remain with what you were looking for. How much C7H11ClO3 is needed? So equals, and you're going to obtain the answer. So you insert those values into the calculator and you're going to have it. So 500, right, times 178.45, and that divided to 200, to open parentheses, right? Well, if there's something else in the lower case, this case is just to 215. 400, it says 415 grams of C7H11ClO3, right? So basically, that was it. That was the answer to the first one. Okay. What about the second one? Second exercise, which is the most important part for today's class. Assume you have 100 grams of the first compound and 50 grams of the second compound. I'm going to type that in here. Let's say assume. It says you have 100 grams there, and now the data is telling you that you have 50 grams there in the reaction. I'm typing now in the reaction. Okay, what is the limiting reactant? So for you guys, for you to do any kind of recognition for this one, you have to do the following. If you want to know what is the limiting reactant in this part, so you need to do, first of all, according to your notes, you should have taken that if you want to recognize that an exercise has a limiting reactant process, that means it has double data. From previous exercise until now we have been doing, it just give you one data, you do the conversion by using the conversion factors from the chemical reaction, and it's done. But in this case, you're receiving double data. So with the double data, we need to do, first of all, the comparison and the analysis. If you're a master in math, you could do the easily in this math. If you're not, get to work in the following process. It's just we're going to do sort of a little bit of a process, so you're going to check this out. Okay, I am going to put everything back. I'm going to put it there. And yes, as it was before, yes. Okay, now let's work into this part. What is the limiting reactant? How do you know what is the limiting reactant? Well, you would have to do the following. In the first place, you get to work with the values you were provided with. Let's get to work. I'm going to just compare this one to this one. This one to this one. So the first value with the value. So you must compare the two data. That you have to do a stoichiometry or the stoichiometrical calculation between the first two values. Let's get to work. So you have that 100 grams of C7, right? H11 ClO3, right? Let's pass that to moles in the first place, right? I know that 1 mole of C7, right? H11 ClO3, right? What is the mass in grams according to what we did before? The ones who were paying attention, C7 H11 ClO3, yes, 178.45 grams of C7 H11 ClO3. Okay, so if you did that calculation or you pass that, now also you know that 1 mole of C7, right, H11 ClO3, right, is related to what? I am not doing any sort of a calculation, but just relating with the second compound, what I am also being given the data. it's related to 1 mole, right, of C4, H11, N. Got it? And then in the lower case, you pass it now to grams. 1 mole of C4, H11, N. What is the reason I am doing this? Because I need to know the equivalence in grams if I use all of the 100. If I use all of the 100, how much am I going to use from the 50 they are telling me? Or maybe, or then the opposite for seeing which one is the limiting reactant. We're going to see in this calculation. You get to work into that by 1,4-C4, H11. If you find the masses there, C4, right, H11N is going to give you exactly 73 grams of C4, H11N. Okay, then you close the conversion factors, right? Close conversion factors, you know the conversion factors, everything should be canceled out. And you cancel this, grams cancel with grams, moles with moles, moles with moles, and the answer is going to be in grams of what you need in this moment, right? So the 100 grams, if you want to use, you would say that if you want to use the 100 grams of C7H11ClO3, how many grams I am going to need specifically? You insert those values into the calculator and you're going to see the following. Let's see, it says 100 times 73 divided to 178.45, which is 40 specifically. It's going to give you 40. Always try to use 3 decimals in chemistry. 0.900, it says 908 and 8 grams of C4, H11, right? N. Got it? Right? So, okay, maybe you already have the clue in this moment. You perhaps already got that, yeah, okay, Mr. Victor, then that's it, right? So, this is, the reason I'm doing this is for the changing to specific parts. That maybe you were saying that always the smaller quantity is the limiting reactant. I'm proving you it's not. In this case, with 100 grams, if you want to use all of the 100 grams of this compound, you need only 40 grams of the second compound. But guess what? How much I gave you for the second compound? I gave you 50, but you need only 40.9. See what I mean? So then you know what is that is the excess reactant, right? That meaning that that one is the excess reactant, then the first compound is the limiting reactant. Okay? So I want to do an extra calculation just for proving that my point. What if I do the other comparison now from the second to the first one? Because I just did the first one to the second. Let's do the second to the first one. And let's see. It says, the data they gave me, 50 grams of C4, H11N, and you pass it to grams, right? You know that in terms of that, it's 73 grams of C4, H11, right, N, and 1 mole of C4, H11N should be passed there, right? And then also, you know that 1 mole of that, 1 mole of C4, H11N is related to 1 mole of the first compound, which is C7, H11ClO3, right? And then also, you know that the mass, right? 1 mole of C7, H11ClO3 is going to be, what's the mass for that one? We calculated was 178.45 grams of C7, right? H11ClO3. If you got it, then you're going to find a different mass, which is really interesting for working that. Let's pass that to conversion factors and stuff in this moment. So let's convert, and things like that. So you cancel, right? Remember grams with grams, and then you've got moles with moles and moles with moles. And at the end, you're going to obtain a number, right? Which is equals, you insert all of those values. You put 50 times 178.45, and all of that divided to 73 is going to give you a number which is 122.22 grams of what? Of C7, H11, ClO3. So guess what? See that? If you pay attention to this, if you want to use all of the 50 grams of the second compound, you need 122 grams from the first compound. But guess what I gave you for the first compound? I gave you only 100, not 122. Okay? So the second version or the second trial I just did is impossible. So that one, this one does not exist, right? That one does not exist. That one is impossible. That one is not doable. So I want just to cross it out and say, no, this one is not. So I'm sticking to the first one. The first one gives me accurate values. So meaning that, what do I mean with that one? To change the, because I love this color, that means all of this, that the first compound is the limiting reactant. So I'm going to text there, this is the limiting reactant. Why is that? Because in your notes, you should have put that the limiting reactant is the one that's been used up totally. I'm using all of the 100 that I was given. So the first compound is the limiting reactant, okay? Meaning that the second one is the excess reactant. Why is that? Because I have it in excess. I only need 40.9, but I have 50, right? If you got that part, I hope you took your notes. I'm going to clear all of this calculations, and then I am going to move to the second part of this exercise. Okay, so let's move to the, we did the first one, right? We did the limiting reactant. Let's go to the next part, which is what is the excess reactant, and so on, so on, so on. The limiting reactant, we know, which is what? The first compound, C7, right? H11, ClO3. Good. So basically what I'm going to do is just copying this one. The limiting reactant is going to be that one because I have that one, 100 grams. What is the excess reactant? The excess reactant is going to be the second compound, right? Put it there. And what else? It says how much is in excess. Let's see. Well, by calculation, I just calculated that I needed 40 grams, right? You needed 40.908 grams. Remember that? So you would subtract how much is in excess. In excess is 50 grams they gave you minus the 40, right? The 40.908 grams. Okay, that would be equals. And if you do that subtraction, put it into your calculator, you put 50 minus 40.908, right? And it's it, 9.092 grams in excess. Okay, and then for the last question, guys, this is very important for you to understand that. For the last question, it says how much in grams of the repellent. What is the repellent? This one, right? This upper part, the one which is in orange. How much in grams of the repellent will be obtained? So how are you going to do that calculation? You're going to use always the limiting reactant. With the limiting reactant, you do the calculation. Once you have discovered, guys, once you have discovered the limiting reactant, with that one, you perform the calculation of the last one. The excess, you don't care. You don't pay attention anymore. With that one, you should perform the calculation. So you're going to work. And you're right. You'd see 100 grams, because that's the data for the limiting reactant, right, of C7, H11, ClO3, right? And then you do the calculation. I know that that's 178, right? C7, H11, ClO3, 78.45 grams of, and once again, right? C7, H11, ClO3, and the upper part it is 1 mole, and so on. So of C7, you know what I mean, H11, ClO3, right? And then I know that 1 mole of that compound is related to what I am looking, 1 mole of C7, H11, ClO3 is related to 1 mole of C, in this case for the repellent, C11, right? H21, NO3, because the ratio is 1 to 1. And then in the lower case, you're going to put this, right? Then 1 mole of the repellent, C11, H21, NO3, has how much in grams? You're going to see that. You would do the calculation. You have 11 times 12, right? Plus, right? 21 hydrogens plus 14 for nitrogen and plus 3 times 16. If you got it, it says 215 grams of the repellent, C11, H21, NO3, okay? So you close all of those conversion factors or fractions, right? You do the conversion, so on, so on, so on. You pass that there. You cancel grams with grams. In this case, the same values, make sure that those are the same units. Moles with moles, moles with moles. And at the end, what you're going to remain is with the final answer, which is going to be, we do 100 times 215 divided to 178.45 according to one cent. So the answer is going to be 120.482 to be precise, grams of the repellent, right? C11, H21, NO3, okay? That was it, guys. I hope you took your notes and stuff like that. I made this video because I wanted you to keep it for you, practice and watch it again. Okay, I will see you. It was good to work with you guys. Please apply yourselves and work. Remember, academic rigor all of the time.